last time I saw you guys, you were in AP classroom and that was supposed to be test points, right? But as you know, with this group, it didn't go so well. Not the scoring, I haven't even scored them yet, to be honest. But you were at a disadvantage because you weren't here, but they couldn't access it from our network, and you still can't. They haven't fixed that yet. I think McGowan just tried and could not do it. So, no, not McGowan. Miss Mo. She teaches it. Yes, it was her. Somebody did. Oh, my glasses are popping up. Anyway, so what happened is they didn't have nearly the amount of time as the people at home, and they had to go at each other's pace, which was kind of weird because if you couldn't do one, you couldn't just sit there and marinate on it for a bit because I was switching the slides forward. So I decided to make it worth homework points. If that, I might not even put it in my grade book. I'm not sure because I still have somebody in the B group who can't get in. So I'm like, ugh, Jordan, she can't get hers to access. And it's not her or me, it's our network. So it may end up in the grade book, but if it does, it'll be in as a homework assignment out of 16 points, okay? So I will get yours back to you, but what I do want to make sure you have the ability to do is, that's why I gave you this. On Friday, I'm going to have a Google Meet where I go through these. I might not finish all of them, but from the kids who are at home, there was like 20 out of 16, 20 out of 16, 19 out of 16, 18 out of 16, 18 out of 16, but then there were some 11s and a couple 12s. And so I really want to make sure you've got this down. So that's an optional Google Meet on what day?
Friday.
Friday, but your test is then on Monday, so it'd also be good test review. So you don't have to show up, and honestly, if you got a 20 or 19, yep.
Right now, if you go from the classroom, you can't see what our results.
I know, and I can't change it because I had originally clicked on not seeing the results, and I was trying to change it yesterday so they could see theirs, and it said I could not alter it after it's been assigned even to just one person. So I'm like, oh. So I gave them their scores on index cards. I'll give you guys your scores before you leave the same way. So while you're working today, I will just give you an index card that says like 14 out of 21 or whatever you got. And some of you retook it in AP classroom, let me know because that's you did. And I can go see, oh, that helps because that's where I have to grade. All right, so those of you who already went in, we'll go fix that. All right, but if that was rough for you, or if you thought it was really good and I hand you a thing back that says 13 out of 21 or whatever, you might want to join me on Friday. So what we're going to do though today, you're going to do review. As soon as we're done putting a test overview on the back of this or on a blank sheet of paper. So whatever you want. Those of you at home, blank sheet of paper. B and DLs at home, you have to submit your notes today on the Google form to get credit for today. You guys don't because you're here. Probably most important day of the chapter right now in these next 20 minutes. All right? So we're going to get the whole chapter. It was called Advanced Techniques of Integration. We're going to first list the non-advanced ones. Okay? So we're going to first talk about AB integration because it's on your test and it always is part of it. Don't forget all the stuff from AB about integration. In particular, what am I going to write? U sub is huge and it's on your test. Make sure that always is actually what you try first. Who do you let U be when you're trying to see if it's set up for U sub? Go give me one of the things. You're like, I'm going to let U be the denominator. If it's a fraction, go with denominator. Because remember what you're hoping is that if this is your U in the denominator, you're hoping that if you take its derivative, it's living where? In the numerator. Might be as a multiple up there, but it's living in the numerator. Sometimes we'd say 1 over U du. Who does that pass off to? Natural log, absolute value, yes. So, and plus C, but I can't fit it on the screen. If it wasn't a fraction, exponent. And whoever said that, when is it an exponent? When what's in the integram? E, yep. We're trying to generate e to the u du. Don't forget, the du needs to be generated as well, fraction corrections. The antiderivative of e to the 8x dx is e to the 8x times, not 8, but 1/8. right? So watch out for that. We've done that in AB. The next one is the inside function. And I'm not going to do any examples. I'm just talking through, okay? Also from AB, maybe there's one that makes a heart. And what did we say you can do if there's a heart? Break it apart. What do I mean by that? Well, if this was x squared minus 3 and this was x, it's not u sub, right? But if I break it apart, it's x minus 3 over x. And I can integrate them separately. So don't forget that. It's easy to miss, right? Another one from AB that I don't want you to miss is maybe it's long division from AB. Katie, how do you know when to try long division? Yes, when it's polynomial over polynomial. So I'm just going to put p of x over q of x. And the degree on the top is greater than or equal to the degree on the bottom. All right, so you can write that if you need to. Will I have a bunch of those? No. Will I have a bunch of hearts? No. I might have one heart and no long division, one long division, no heart. This isn't Calc AB. Will I have u sub? Yes, because it's always king. Okay? Next up, then we started with our new techniques. The first one we did was the inverse trig. And it's really good, guys, if you know what the triggers are for this. So when I talk about does it pass off to arctan or arcsine, we won't pass off to the other ones. How do you know if it's set up to pass off to arctangent? What does the integram look like? You're like, oh, that might go to arctan. What's happening in the denominator that makes your brain think that it might go to arctan? Where?
A squared plus b squared.
Yeah, there's some number squared plus some function of x squared. The numerator can be any constant. So I'm just going to put a 1. If it was a 5, I'd throw it out front and make it a 1, right? Now, do we remember, because you need to know, what that passes off to? 1 over a arctan what? Unit analysis plus a or if it's a definite integral. Next up, the arcsine is almost identical, except it's a little uglier, right? And that passes off to just arcsine u over a. The group yesterday, though, was working on that worksheet number 10. Hopefully you guys are done with it. Did you turn it in already? Because you guys can turn it in. You can just give me the paper copy if you're done. The other group had to wait because they need to take these notes. So on the Google form, it asks them for the notes as well. If you guys just have it with you and haven't done the Google form yet, I'll just collect it. All right. So this is what happened on their worksheet number 10, though. They ended up with, let's draw an arrow. Arctan, I think it was infinity minus, does this look familiar? Those of you, arctan 0. And this is pre-calculus, but they had forgotten what arctan meant. Which makes sense, but it does pop up in this class quite a bit. So let's go draw a little graph. When you do tangent of an angle, right? What's tangent pi fourths? Go ahead and tell me. 1. Sine there over cosine there, and they're the same. Boom. Tan inverse or arctan undoes tan. It's its inverse operation, like squaring and square rooting. So if I arctan the left, I just get pi fourths is equal to arctan of 1. You're asking yourself what angle has that tangent, not what's the tangent of that angle. It's the opposite thought. Does that make sense? So if you know your graph of a tangent from algebra 2 / pre-calc, that it's periodic, but it's what we call its primary period from negative pi halves to pi halves. Should make sense to you why the asymptotes are at pi halves, because we're sine over cosine, and cosine pi halves is 0. You can't divide by 0, correct? So now that you can see the graph, at what angle is arctan going to infinity? Go ahead and tell me. Pi halves. Yep. At what angle is the arctan 0? 0. So make sure you know arctan infinity is pi halves. What's arctan negative infinity? Negative pi halves. And what's arctan 1?
5/4.
There it is. Those are the only 3 you would be asked because the other ones are too ugly. All right, so that's our inverse trig. After inverse trig, we passed off and did a new one, and it was a fun one called by parts. 4 by parts, again, the trigger. It looks like u dv is equal to uv, uv, minus the integral of vd, uvd, right? However, how do you know when to use it? And incompatible functions, 90% of the time, but 100% of the time for AP. So I'm going to keep them incompatible, just so you don't miss your by parts, because you're like, oh, it's sine squared, I could break it into sine times sine. I won't do that to you. So we're incompatible functions, e to the x paired with sine x cubed paired with cosine, natural log paired with x to the 4th. What was our acronym for deciding who's u? Yes, logarithmic, inverse trig, algebraic, trig, and exponent. All right, but what College Board does sometimes do, and we've seen it, it happened on AP Classroom for I think 2 of them. You have no clue what the functions are. Like this in here isn't x cubed and this natural log of x. They had it like this. Let's say h of x and g prime of x dx. Usually those are definite integrals. Now you have no clue. So it's not about you. It's about the one you can integrate. Which one do you know the antiderivative of? G prime. And that's the dv. Because the derivative of what is g prime? G. And then you work with it as normal. Right? So your u would be h. This would be h prime. And they have to give you a little bit of information. So usually those will say they're tabular, or you know how they go. You know how they roll. So that's our by parts. After by parts, we're just hitting all of them. I got to make sure. I want to do them in the order of your notes. So after by parts was, are we on number 3 or 4?
4.
All right, 4. It was partial decomp. You guys are great at it. But do you know when to use it now when it's going to be all mixed? What's the trigger for partial fraction decomp? Incompatible functions for by parts. But for decomp, what's in this integram that triggers the process?
2 different
Yes.
things in the bottom.
What are those things? Non-repeating. So 2 different, she said. Non-repeating. What kind of factors? Whoops.
Linear.
Linear. Yes. So this might be an x minus 5, and this might be an x plus 6. But they're non-repeating linear factors. You might need to factor to find them, right? So it might be a quadratic down there, like x squared plus 8x plus 15, and you're like, oh, that's x plus 3, x plus 5, non-repeating linear factors. All right, on the top is either like a constant or something x or whatever. So let's go over here and remind you of how you break it up. You put a over the first one plus b over the second one, and you decompose it. Do you remember how to do it? Yeah, look in your notes if you forgot. There's plenty of examples. I want to give you a bunch of work time today, and I'm nearly done. So after partial decomp, again, we'll be going over a couple of those on Friday. So if you're like, I wanted to do an example, show up on Friday, okay, for the Google Meet, because there were several of those. The next thing after that was the L'Hopital's rule. Kind of a weird place for them to throw it, but that's where it goes. The advanced L'Hopital. And again, you can see examples in your notes, but L'Hopital's rule is used when you're finding the limits. So it's when it's in your face and it says, what's the limit as x approaches c of this stuff? Right? So you'll know when you're going to L'Hopital's rule. Non-advanced might still be on the test. Non-advanced is when it immediately goes to what? You don't even have to mess with it. 0 over 0, so non-advanced, 0 over 0, or the infinities over the infinities. I might have one on there. I should, right? You need to know that. For advanced, so this is non-advanced, for advanced it goes to the other indeterminate forms. And I'm not going to do all of them. This isn't a big skill in here. I might pick 2 of them. I might pick the 0 times the infinities, plus or minus. Well, it can't be 0 times. That's the kind where you try to rewrite one in a denominator. So it's 0 over 0. Remember doing that? All right, so you'll know. The other one is infinity minus infinity. That's indeterminate as well. You might want to look in your notes at how to deal with that. The last one, and it's kind of all in one, so I'm going to put it in a box again, is when you have the power ones. I think the other one was infinity to the 0 or 0 to the infinity. It was infinity to the 0. I even forget what they are. But the trigger for these is that in the exponent of the original, there was an x. X in exponent. They stand out. I remember when I gave the worksheet on them, I said, flip it over. Which ones are you going to do this process on? And immediately you guys are looking at those exponents. When I said this process, do you remember what happened when we had maybe limit of x to the 1 over x as x approaches, let's say 0? I actually think this one's 0 to the infinity. Do you remember what we do?
Natural law.
It's natural log. Yes, and you might want to look at that process. I will have one of those for sure, okay? So 1 for sure. Hello.
Hey, sorry to bother you.
No problem.
Do you have students, do you know,
It'll be this group, yeah.
do you have someone who has their login and their password I can try quick? I'm just trying to
Yes.
do it.
Yep, so just a second, I'm going to pause. All right, was I done talking about this? Sorry, guys, at home, somebody came in, a tech guy, to talk to me. All right, so that was the L'Hopital's rule, and after that, our last big one was improper integrals. Improper, and we just finished that, so I will have a couple of those on the test, I think like 3, where I ask you, does this converge or diverge, show all your work, use the limit process, that type of thing. You'll be practicing similar ones in your packet. So this was so fresh, I'm not going to talk about it. And then again, we're going to circle back to AB. There's stuff in AB that required you to integrate that could pass off to this. You had a couple in your homework with the revolving solids. I might ask you to revolve something around an axis and one of the limits is infinity and it'll pass to an improper integral. That's fair, right? Remember, we do pi times big radius squared minus little radius squared dx. I will not throw shell method at you. It'll be very straightforward. That was just me yesterday, trying to challenge you. All right, so don't forget that. Could be area. Could even be particle motion. Because watch. What if you're given the, let's say, acceleration of something, and I ask you for the velocity? You're nodding, right? That's legal. That you could integrate your acceleration to get the velocity. But usually it'll be at a specific time, so it'll usually be a definite integral, right? Or at a specific time, so usually you have to go find that c. Remember doing that? I'd have to give you a point to put on there. I think that's about it. That's fair game. So that's it. That was 18 minutes of what you need to know. The next 40 minutes-ish are going to be working on this worksheet. Those of you at home, don't click off yet, because we're just going to go take the first 12 and say, hey, look at it. What would you do? And while we're doing that, can you give me your login information for AP Classroom? Do you mind? And I'll assign something just to you. Yeah. And then I will, here. Guys at home, they're trying to fix the AP Classroom issue. Miss Cage complained, Kirsten, Miss Anderson did, and then this morning Miss Mo. But I think finally enough of us have complained that they're doing something about it. Because actually, I think Miss Cage complained. All right, are you ready? So in 1 through 12, we're not going to do that. We're going to take 2 minutes. And I'm just going to let you think for about 10 seconds and say what you would try first. Number 1, U sub. Use that inside function, and it generates the numerator. That'll be great. How about number 2? U sub again. Yep. Good, you got first two right. Number 3, what triggered by parts, Em? Incompatible function. Number 4, it is decomp. U sub I went to first, didn't you? The derivative of the top did not live in the numerator, but bottom factors has a partial decomp flows in. Do you see how this goes? It looped up. Now this is where you see if you know what you're doing. Number 5, it is U sub, because the derivative of x squared plus 5x plus 1 is 2x plus 5. 4 times it, yeah, so with a 1/4 correction, make sure you show all your work. Number 6 is screaming what? 5 parts, it could go tabular. Do you remember how when, yes, they're nodding, so when your U choice is algebraic, right? You don't have to do a tabular, but you could. Number 7. This one don't blur. Raise your hand when you think of a way to attack number 7. Probably the trickiest one of those 12. U sub failed. Bottom doesn't factor. The degree on the top isn't greater than or equal to that on the bottom. Long division doesn't work. I am stuck. What could you do? Yeah. It looks really inverse tricky, and it can go there. If you what? Part. If you make it x over x squared plus 4, it'll pass to U sub. Plus 2 over x squared plus 4 gives you your inverse trig. So it's 2 different ones hiding in one. That would be mean if I did that, but I wanted to put one on. I won't do that to you, but I like it. Number 8, what's it screaming? Decomp. Number 9, what's it screaming? Do you see how you're getting good at deciding? I feel good, it's good. Number 9, what's it screaming? U sub. U is ln x and du is 1 over, it's the rest, that's u to the 4th du without even messing with it. What's 10 screaming? By parts. Excellent. If you're like, I wouldn't know that, you need to study. Number 11, what's it screaming? Inverse trig. Which one? Arctan. What's number 12 screaming? Arcsine. Good. You see how you just need to know how to work those. I'm going to stop this. You guys get the rest of the time, the half hour to work. I'm going to be working with the text.